Welcome to the deep dive. Today we're digging into something quite specific but really important. How do we connect the Khmer language with, well, the latest generation of AI language
Yeah,
models?
it's a fascinating challenge.
Our guide for this is a paper called Insights Machine Translation, Bridging Khmer Language and Large Language Models, LLMs. It just came out, authored by BYY Rina, Chunda Sovazal, Tang Ngunli, and Kong Mary folks from AI Forum, Techo Startup Center, and the Ministry of Economy and Finance.
A strong lineup.
Absolutely. So our mission today is pretty clear. We want to understand why building these big AI models directly for Khmer is, well, proving difficult right now.
Right. What are the hurdles?
Exactly. And crucially, what's the clever alternative this paper suggests to let Khmer speakers tap into the power of the existing big models? And, relatively quickly.
A bridge, essentially.
That's the idea. So if you want to get a good handle on this without getting bogged down in super technical details, stick around.
Okay, so kicking things off, the paper makes this really clear point. These amazing LLMs we hear about all the time, they're mostly brilliant in English.
Right. That's where the focus has been.
Exactly. Models like Fine 3, Llama 3, they've done incredible things, as some recent work has shown, but their strength really comes from having just mountains of English data to learn from. High resource languages.
Yeah, that makes sense. And we are seeing some regional efforts, right? Like CLLMs and CLAN.
We are, yeah.
Hmm.
And that's exciting progress, definitely. But as the paper notes, based on research from last year, their ability to really handle Khmer effectively, well, it's still developing. It's not quite there yet.
And then you've got the big commercial ones like ChatGPT or Claude. People might think, can we just use those?
Well, you can try. But there are a couple of catches the paper points out. First, the cost. Because of how these models break down text, it's called tokenization languages, like Khmer can end up being surprisingly expensive to process.
Because the word structure is different.
Sort of, yeah. It often takes more tokens to represent the same meaning. And second, the actual performance you get for Khmer might not always be, top-notch. It could be a bit hit or miss.
Okay. So if we step back, why is it so hard to just build a really powerful Khmer LLM from the ground up right now? What are the main roadblocks?
The paper boils it down to three main things. First, data. Just not enough high-quality, large-scale Khmer text available for training. That's the fuel these models run on.
The raw material.
Exactly. Second, compute. Training these massive models takes enormous computational power, which isn't always easily accessible.
Right. The hardware requirements are huge.
Definitely. And third, skilled people.
Yeah.
You need engineers with very specific expertise to build, train, and maintain these complex systems, and there's a shortage there too.
Data, compute, skills. That's a tough trio of challenges.
It really is.
Okay, so given those challenges, what's this alternative approach the paper is championing? This bridge.
Right, the bridge. The core idea they propose is to focus, for now at least, on high-quality machine translation, or MT.
Machine translation.
Okay, now basically MT is just using computers to translate from one language to another.
Yeah.
Simple concept, right?
Yeah, we've all used Google Translate or something similar.
Exactly. But here, it's positioned as something more strategic. It's seen as a way to unlock access to all the information and AI capabilities that currently exist primarily in English. It helps bridge that digital divide for languages like Khmer.
So use translation as the key to unlock the English-centric AI world.
Precisely. Think about all the knowledge locked away in English. MT could make that accessible. It's a powerful idea.
But translation itself isn't always perfect, is it? I mean, languages are tricky.
Oh, absolutely not perfect. And the paper acknowledges that. Languages have different structures, grammar, idioms, all sorts of nuances. It's not just swapping words. And interestingly, they mentioned this asymmetry, apparently. Translating from English to Khmer tends to be a bit more straightforward than translating from Khmer back into English.
Oh, that is interesting. Why would that be?
Well, the paper doesn't dive super deep into the linguistic reasons, but it's a known challenge in the field. It adds another layer of complexity to using MT as this bridge.
Okay, so let's talk tech for a moment. How does modern MT actually work? What's under the hood?
So the standard approach now, the one the paper mentions and shows in a diagram, figure 1, is based on something called an attention-based encoder-decoder neural network.
Sounds complex.
It is, but the concept is kind of elegant. Basically, you have two parts. The encoder reads the original sentence, say in Khmer, and squishes it down into a mathematical representation of its meaning.
Okay, like a summary of the meaning.
Sort of, yeah. Then the decoder takes that meaning summary and generates the translation in the target language, like English, word by word.
But where does the attention part come in? You mentioned that.
Ah, that's the really clever bit. As the decoder generates each word of the translation, the attention mechanism allows it to look back at the encoded representation of the original sentence and focus, or pay attention to, the parts that are most relevant for predicting the next word in the translation.
So it's constantly checking back with the original meaning?
Exactly. It's like it's asking, okay, to generate this next English word, which part of the original Khmer sentence is most important right now? It makes the translation much more context aware.
Wow, okay. That's pretty sophisticated stuff. What do these models need to learn to do that well?
They need data, lots of it. Specifically, they need parallel corpora. Think of huge databases of sentences where you have the sentence in Khmer perfectly aligned with its accurate translation in English.
Like a massive Rosetta Stone.
That's a great analogy, yes. The more examples it sees, the better it learns the patterns between the languages. But as we said, getting those massive, high-quality parallel data sets for Khmer, that's a major hurdle.
Right, the data scarcity problem again. So how are researchers trying to get around that specific bottleneck for MT?
The paper points to a couple of smart strategies. One is transfer learning. You take a model that's already been trained on tons of data for other languages, maybe English, French, English, German, whatever,
Okay.
and then you fine-tune it using the smaller amount of Khmer English data you do have. The hope is that the model has learned general translation skills it can adapt.
Leverage what it already knows.
Precisely. The other approach is using these big general-purpose LLMs, even if they weren't built just for translation. You can give them specific instructions and examples, instruction fine-tuning, to teach them how to translate. The paper even shows a template, like giving it a Khmer sentence and the English equivalent.
Ah, okay. So you're kind of coaxing the translation ability out of a model that already has broad language knowledge.
Exactly. You leverage its existing world knowledge and language understanding.
This is where it gets really practical then. The paper talks about MT-embedded LLMs. What does that actually mean, and how does it let us use those powerful English models for Khmer?
This is really the heart of their proposed solution, shown nicely in their figure 2. The idea is to use good quality MT systems, both Khmer to English and English to Khmer, as intermediaries.
Like a translation sandwich.
Huh. Sort of, yeah. So say you have a long document in Khmer and you want to use a powerful English LLM to maybe summarize it.
Okay.
You'd first use your Khmer to English MT system to translate the whole document into English.
Step 1, translate to English.
Right. Step 2,
Yeah.
feed that English text into your state-of-the-art English summarization model. The paper mentions BART as an example.
Get the English summary.
Yep. Step 3, take that English summary and use your English to Khmer MT system to translate it back into Khmer.
And presto, you have a Khmer summary generated using a powerful English AI.
That's the workflow. It lets you leverage the best available tools, even if they don't directly support Khmer.
That is a clever workaround. Does the paper give other examples?
It does. It mentions summarizing a long Khmer article, just like we discussed, and it flags that the quality of the final result obviously depends on both the power of the English LLM and the accuracy of the 2 MT steps.
Right. If the translation is bad, the summary will be based on bad input, or the final Khmer output will be garbled.
Exactly. The MT quality is crucial. It's the potential weak link.
But the potential is still huge.
Oh, definitely. They even suggest things like chatbots for rural healthcare. Imagine using an English medical LLM's knowledge, accessed via MT, to provide real-time health advice in Khmer. That could be transformative.
Wow. Okay. And this idea extends beyond just text, right? The paper mentions MT-embedded VLMs, visual language models.
Yeah, this is taking it another step further. VLMs are AI models that understand both images and text together. Think of models like Soren's 2.
So they can see and read.
Basically, yes.
Yeah.
And the MT-embedded approach, shown in Figure 3, allows Khmer speakers to interact with these too. They give the example of visual question answering, or VQA.
How would that work?
So you, the user, could upload an image, maybe a picture of something you don't recognize.
Okay.
Then you could ask a question about the image in Khmer.
Like, what is this thing in Khmer?
Exactly. The system would then use MT to translate your Khmer question into English.
Translate the question.
Then it feeds both the image and the English question into the powerful VLM.
The VLM analyzes both.
Right. It looks at the picture, understands the English question about it, and generates an answer in English.
And the final step.
Translate that English answer back into Khmer using the English to Khmer MT system. So you get the answer to your visual question in your own language.
That's actually mind-blowing. Using translation to unlock visual AI. The paper had a cultural example, didn't it?
It did. Imagine uploading a photo of, say, a traditional Khmer musical instrument
Okay.
and asking in Khmer, what's this called and when is it played?
Right.
The system translates the question. The VLM identifies the instrument in the image, let's say it's a trochmer, retrieves information about it, generates an English answer like, this is a trochmer, often played at ceremonies, and then translates that answer back into Khmer for you.
Incredible. That opens up so many possibilities for learning, for accessibility.
It really does. It connects Khmer speakers to these cutting-edge multimodal AI capabilities.
So this MT as a bridge approach is the practical solution for now. But what about the longer term? Does the paper say we should just stick with this?
No, not entirely. It makes very clear that while this MT embedded strategy is crucial for the near term, the long-term goal should absolutely be to improve the